Hello. Today we're going to be going over exam prep question 2 for discussion 4. So this is the question at hand, and what we have to do is write a method flatten that takes a 2D array X and returns a 1D array that contains all of the arrays in X concatenated together. So we have an example here of an array 1, 2, 3, an empty array and 7, 8, and this is a 2D array. And eventually, after flattening it, we should have just a 1D array containing 1, 2, 3, 7, and 8. So just to think about exactly what we're doing here, we have sort of something like this: 1, 2, 3, something empty, and then 7, 8. And this is like wrapped up inside a 2D array, right? And somehow we want to take this, which is a 2D array, and turn it into a 1D array. So to do this question, we want to be familiar with how 2D arrays work, how we want to iterate across elements inside a 2D array. And yeah, that's essentially what we need to do. So we basically want to understand how we can access every single element in this array in order, and then add it over here. And notice that this array isn't square, so we have to take that into consideration. Okay. Let's take a look at the code given in this problem. Whenever we're given like a skeleton, it's a good idea to understand maybe what each part of the skeleton is doing that we have been given, and then maybe try to figure out, okay, what is like the missing code, in a general sense. So let's take a look at this first section right here. Right, this part seems like we initialize this integer called total length, and then after we do some stuff in the for loop, we are going to create a new array. And notice that we're returning the array. Notice that we're returning this same array. This should tell us that that array is going to be actually our final output array, and total length is just the total length of whatever array we have been passed in. And when we talk about total length, it really is just the number of elements. So it's up to us then to figure out, hey, how are we going to figure out all the total number of elements? So let's just write that down. And elements. Okay, so now that we have understood that, okay, this is where we find the total of elements, now we need to know what are we going to do over here in this section. So after we know the total number of elements, what we really need to do is to copy these elements in some way, add them into the array that we have. So there might be a lot of ways that we could consider doing this, but no matter what, we need to iterate over every single element inside of our array, and add all of them to the other array. So this is essentially what we need to do. Okay, so how do we go about doing both of these steps? So for the first step, there aren't too many different ways that we could possibly do this, right? And we're only given one line, so we do need to do this in one sort of, there's a more like similar way that we would be doing this. So when we're going to loop through or iterate over in a 2D array, and we're looking at every single, sorry, the length of like every single element, we're actually really, with one for loop, all we can do is we can look at, you can treat each of these arrays as an element and then figure out its length, right? So the two ways we have of looping through items is to either use a for each loop, right? So in a for each loop, we'll already be going through order. In Python, you would have been used to something like for element in array, that's a for each loop. So in this case, we can go int, and this is like an int array, and we're going through every single element in X. So this is one way we can do it. Another way we could do that, let's do this over here, is by doing a classical for loop that we know in Java, and that would be for int I equals 0 when I is less than x length I plus plus. So we can use either of these methods in order to iterate over our 2D array. Then we need to keep adding to the total length depending on what the length of this element or the length of these 2D arrays are. So when we have array, we can do total length, and every single time update total length by adding its original, whatever length that was, and then the length of the current array that we're looking at. So right now we're looking at this array, just R. So we can say R dot length. If we were to be looking at this other one, then we can't just do X or I dot length, right? Because I is actually just the way we're indexing into X dot length. It's not the actual object, it's just an integer. So in that case, analogously, we would do total length plus equals X index into I. So in the example that we were given, I would be 0, 1, and 2, and we would take its length. Either way, whatever method we choose to use, I prefer using the for each loop. I think it's more readable. But whatever you choose to do, we should be going and looking at every single one of the 1D arrays inside our 2D array, updating total length, and then moving on. Okay, so now that we have created our new array, we need to figure out how we can copy stuff into this array. And we can either use array copy, which will directly copy things into the array in some way, and that you have to be a little bit creative with, or we can simply use assignment statements to copy things over. So we've been given an index, called a index, and it's been initialized to 0. The naming of this variable should tell us that we're going to use a index in order to index into our array. So the for loop should actually be used for indexing or for iterating over our past in 2D array. And then we use a index as a way for us to index into the array that we're going to output. So what that tells us is that at the end of every single iteration of our for loop, we should be updating a index in order to keep adding elements to our array. So we can say here at the end of every iteration, we'll update. Okay, now we want to actually iterate over our 2D array. I'm going to continue to use the for each loop sort of syntax, but you could also use the other syntax. It's totally up to preference. But in this case, we can do our same looping through X, but now we actually want to access every single element. When we want to access every single element, what we have to do is we have to do another for loop. So now we would loop through every single element inside each of these arrays that we're being passed in. So for integer call element in array, we want to loop through all of that. I realize we need to put our curly brace. We need to have our curly brace one up so we can complete the for loop and not have syntax errors. Okay, so with one line, what are we supposed to do here in order to continue to finish our whole the whole problem, right? We only have one line left, and what we're doing is it says iterating over all elements, add to array. We should say is add to array in order, but because we're doing a for each loop, we're actually are looping through everything in order. So for the example that we're given, in each run of the inner loop, we'll be going in order of 1. So let's just think about this, right? When we look at this first array, the 1D array that we're going to look at in the first pass, this array is 1, 2, 3. Then in the second loop, we're going to look at 1, and then 2, and then 3, right? And so on. So when we look at the second run, there won't be anything in that array, and then we do 7 and 8. So we're actually going exactly in the order that we want to return our list in, which is perfect. So what we can do is we can set A at A index equal to the element that we're looking at each time. And that way, we should be filling up our A in the correct order. So that's the final code. And let's just run through for the example that we're given to make sure that this all works. So I'm just going to erase some of this stuff on the side so we can sort of go through all of this. Okay, cool. Let's look at this, right? So we're passing X, and that's 1, 2, this 2D array right here. And when we look at the first for loop, we're going to go through every single 1D array in X and add its length to total length. So on the first run of this for loop, we have the array 1, 2, 3. Its length is 3. So the length is 3. So 0 or total length equals like total length will equal 3. Okay, on the next run, we actually have an empty array, and its length will be 0. So we're not going to update total length, or it'll be total length will have 0 added to it. Finally, the array that we have is 7, 8. Its length is 2. So we're going to update total length to be 5. Because 2 plus 3 equals 5. And now we're initializing a new integer array, which is our output array, and that is a total length of 5. Right? So it's a new int array. I'm just going to draw it here. Okay, with five elements, and it's empty. Normally that actually initialize everything to 0, but for sake of this illustration, we're just going to leave it. Okay, now finally, we're going to loop through every single element, and we've seen that each of these inner inner for loops is going to look through every single index, right? So as we look at each element, we go into here for the first one, and we set a at a index is equal to element. And initially that's 1, or the index is 0 and the element is 1. Then we update the index. So now a index equals 1. And we look at the next inner rotation or inner iteration, 2, 3, 7, 8. So this is our final return, and we see that it works for this example. And yeah, that's about it. Hopefully you guys learned something today from this problem. See you guys next week.